4-3, Part 2. Triangle Congruence by ASA and AAS. Alright, so we went over ASA in the previous video. We know that stands for angle, side, angle. Now in this video, we're going to go over AAS. You've probably figured out the naming convention by now to know that this means angle, angle, side. Alright, angle, angle, side. So today our objective is going to be to prove two triangles congruent using the angle-angle-side theorem. And our focus question, which we will answer at the end of the video, will be when can you use a non-included side to prove triangles congruent? Alright, so let's get into the lesson. Now, we've learned, this is the fourth way we've learned to prove triangles congruent. Alright, so it says you can also prove triangles congruent by using two angles and a non-included side as stated below. So our angle-angle-side, or AAS theorem, states if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent. Now, here's a picture. If you're like me, you like the pictures better. They're usually easier to understand. So here we have angle A congruent to angle D, angle B congruent to angle E, and then if you notice, we have a non-included side. All right, we have a non-included side. Now, this non-included side, it can't just be any two of the non-included sides. It has to be the same non-included side in both triangles. What do I mean by that? All right, here we have A marked congruent to D. Well, if you notice, our non-included side, AC, all right, it's the side that is next to angle A, not angle B. So down here, since A and D are congruent angles, the non-included side will have to be the side that is next to angle D because it is congruent to angle A. All right, if this tick mark had been on FE instead, it would not be the same non-included side. So therefore, you would not have enough information to prove these two triangles congruent. Since in this case it is the same non-included side, then both these triangles are congruent. All right? Important thing, it has to be the same non-included side. An easy way to tell, make sure it touches the same angle in both triangles. All right, make sure it touches the same angle in both triangles. Okay? So here's a little proof of AAS. All right, so it's given that angle M is congruent to angle K, and that these two lines are parallel, MW and RK. So our first two statements, you don't really have to break these up. They did, but you don't really have to. Angle M is congruent to angle K, that's given. Side WM is congruent to RK, that is given. So now we know that angle MWR, so this angle here, is congruent to KRW, this angle here, and our reason is they are alternate interior angles. Because here we have our parallel lines, and then this is our transversal, which makes these angles here alternate interior angles, and therefore they are congruent. All right, therefore they are congruent. Let me dress this, clean this back up now. All right, so we know this angle is now congruent to this angle. And of course, we know that WR is congruent to itself because of the reflexive property of congruence. So now, if you notice, we have two angles here, congruent to two angles here, and this is the same non-included side in both triangles. Because remember, it's touching angle W in this triangle, which is congruent to angle R in this triangle, and it's also touching angle R. So this is the same non-included side in both triangles. So therefore, our triangles are congruent because of angle-angle-side. All right. So Now I want you to try one. And yes, it's a proof. This is your U try. Okay, so pause the video, take a few moments, and figure it out. All right, so let's get proofing. All right, my favorite proof is the two-column proof, where you have your statements on one side and your reasons on the other. Now, for these proofs, you basically just write down what you do in your head as you're thinking through these things, trying to figure out if they're congruent or not. All right, so step one. Step one is always, always, always easiest, because you always want to start with your given information. All right, and the reason is given because it is your given information. They gave us that information. All right, now this is where we're going to. We need to be able to prove these triangles congruent. All right, so number two, how can we get to these triangles being congruent? Well, we know S and Q are congruent, but what does this mean? It says it bisects SRQ. It says it bisects this angle right here, which means if it bisects the angle, it means it cuts it directly in half, right? Which means angle SRP and angle QRP are also now congruent because line RP bisects this angle. And when, so like I said, when something bisects, it cuts it directly in half, exactly in half. So angle SRP is congruent to angle QRP. And number two, how do we know that? Well, that's our definition of bisects. All right, definition of bisects. And reason three, oops, that's not supposed to be a negative three. Reason three, all right, we have an angle here, an angle here, an angle here, an angle here. So let's try to make this proof angle, angle, side. No, this is not a coincidence. All right, so what about PR? Is it the same side in both triangles? Yeah. Is it the same length in both triangles? Yeah. So PR is congruent to PR. That is your reflexive property. Oops. All right. So now we have two angles and a non-included side, all prove congruent. So now we can end this proof. We can say triangle SRP is congruent to triangle QRP. Now, if you notice, the last statement in your proof is always the statement you're trying to prove. Okay, that's what you're going to end with for the statements. And our reason here is because angle, angle, side, because we proved two angles and we proved a side. All right, so our reason is angle, angle, side. Now, number three, it says, in problem three, how could you prove that triangle WMR is congruent to RKW? We're not going to worry about that. I'm not going to make you do that. Only do A. I'm not going to make you do that. Just do A. All right? Because I scrolled down and you couldn't even see the triangle up there. So there we go. There's your proof. 4 lines. There's not really any set length of a proof. It's just as long as it needs to be. If it takes 5 steps, if it takes 6 steps, it takes that long. If you can do it in 4, good. Just make sure that you prove enough to answer the question at hand, or to prove the question at hand. All right. Problem 4, determining whether triangles are congruent. So use the diagram at the right. Which of the following statements best represents the answer and justification to the question, is triangle BIF congruent to triangle UTO? So let's look. Well, here we have two angles and a side. Here we have two angles and a non-included side. Is this non-included side the same as this non-included side? If you said no, you are correct. So now let's see. So we cannot use, that means we cannot use AAS because these are different non-included sides. So yes, the triangles are congruent by AAS. No. No, angle FB and OT are not corresponding sides. That's our correct answer. This says yes, they're congruent by AAS. Nope. And then no, B and U are not corresponding angles. That's wrong too because B and U are corresponding angles. All right, and if you read this down here, it says the same thing. The important thing to remember with AAS, all right, the important thing to remember with AAS, the non-included side has to be the same side in both triangles. In this case, it is not the same side in both triangles. Okay? The easiest way to tell is, like I said before, they both have to touch the same angle. Like when you, for instance, here, I is congruent to T, so the side in the first triangle would have to touch I in order to use side OT in the second triangle. All right. If you wanted to use the top triangle, the side BF in the top triangle, then the bottom triangle, the side would have to touch angle U. Okay. All right. It has to be that way. It has to be the non-included, it has to be the same non-included side, meaning it has to touch the same angle, the same congruent angle in both triangles. All right. Here's another U try real quick. It says, are triangle par and triangle sur congruent? Explain. So take a few minutes, pause the video, and figure this out. All right, so are they congruent? Well, let's see. We know this angle is congruent to this angle, and we know that these two angles are congruent because they are vertical angles, and we know these two sides are congruent. Okay, well, I need to put two arcs on this. Now, do we have angle side? Yes, we do. So yes, they are congruent, and they're congruent by AAS because, whoops, because corresponding, oops, two corresponding angles are congruent and a non-included corresponding side and non-included corresponding sides are congruent. All right, because here we have angle side, angle side. These are corresponding sides because they both touch angle R. Well, you can't call it angle R, but I'm going to call it angle R for simplicity's sake. Both of these sides touch angle R in each triangle, so therefore they are the same non-included side, and they are congruent, and then two angles are congruent as well. So we have angle side congruency here. All right. Remember that focus question from the beginning? Let me center it up here. All right, so here's that focus question from the beginning. When can you use a non-included side to prove triangles congruent? Answer, two triangles are congruent when they have two pairs of congruent angles and one pair of congruent non-included sides. All right, so that was our focus question. Two triangles are congruent when they have two pairs of congruent angles and one pair of congruent non-included sides. All right. So before we get to that, now we know four ways to prove triangles congruent. We have side, 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 angle, and angle, angle, side. All right, so now we know 4 ways to prove them congruent. Here's your ticket in the door. It says, number 1, which postulate or theorem could you use to prove triangle ABC congruent to triangle DEF? And number 2, suppose angle E is congruent to angle I, and side FE is congruent to side GI. What else must you know in order to prove triangle FDE congruent to triangle GHI by angle side angle and by angle angle side? So number 2 is really a 2-part question. You're going to have an A, which is proving it by angle side angle, and you're going to have a B, which is proving it by angle angle side. All right, so good luck with this. Make sure you come tomorrow ready to bust out some problems on these on angle angle side. All right, see you tomorrow.